In this video, we're going to talk about eigenvalues and eigenvectors. Eigenvalues are useful for solving dynamic problems where the solution du dt equals au is changing over time. Let A be an n by n matrix and consider the equation ax equals b. We will let ax equal lambda x, where lambda is an eigenvalue of A. Lambda tells us whether vector x shrinks, changes direction, or remains static when multiplied by A. Verifying eigenvalues and eigenvectors. Let's start a new screen. And we'll let A be equal to 1, 4, 2, 3 in a 2 by 2 matrix. We'll let vector x sub 1 be 1, 1 in a 2 by 1 matrix, and vector x sub 2 will be 2, negative 1 in a 2 by 1 matrix. We want to verify that lambda 1 equals 5 is an eigenvalue of A corresponding to x sub 1 and lambda sub 2 equals negative 1 is an eigenvalue of A corresponding to x sub 2. So we take our 2 by 2 matrix A multiplied by x sub 1, and you can multiply these manually or using your graphing calculator. This gives us the 2 by 1 matrix, entries 5 and 5. If we factor out a 5, we're left with the 2 by 1 matrix 1, 1 times a scalar 5. And this is equal to lambda 1 times x sub 1. Similarly, we'll take matrix A again and multiply it by vector x sub 2. Matrix A has the entries 1, 4, 2, 3. Again, that's a 2 by 2 square matrix. And x sub 2 is our vector 2 by 1. Here we have 2 and negative 1. Multiplying those together, we get negative 2, positive 1. Factor out a negative 1. And we have scalar negative 1 multiplied by a 2 by 1 matrix with entries 2, negative 1. And that's equivalent to lambda 2 times x sub 2. So this concludes our example of a brief introduction to eigenvalues and eigenvectors. Hopefully you found it helpful, and we'll see you next time.